We've got another problem up here on the board. This time this is for position of an object that's thrown up into the air. So here position actually is measuring height above the ground. It's a vertical distance. P of t is given by negative 16t squared plus 28t plus 8. Eventually we're going to be able to see why negative 16 shows up in a lot of these projectile motion problems. That's where you throw an object up into the air and gravity acts on it to eventually pull it back down. Okay, now I know just from my algebra that since this is a quadratic function with a negative lead term, it's going to be a parabola that opens down. And I can easily see that at time 0 we're at a height of 8, so I've just sort of shown that here. Just like with the horizontal movement that we were dealing with here, the object isn't actually following this path. The object would be going straight up and then straight down, because this is just measuring the height above the ground that we have here. We're not taking into account any horizontal distance. I threw an object up, it came back down. Not I threw an object up and forward. We get this horizontal change here because we've given a physical dimension to time. Okay, so we're asked the following questions. We want to find the time that the object is at the high point. So that's going to be, I can see the time of the vertex. We want to find the velocity at that time. We want to find the maximum height, which would be the position, the P of t value at that time. And then we want to find the time that the object lands. That's going to be when it hits the ground. And we want to find the velocity at that time. Okay. Now, these first two questions I'm actually going to do twice. I'm going to do first the algebra way and then the calculus way. Now the algebra way we already know. It's an upside down parabola. The time we're at the highest point will be the t value of the vertex. And that's just going to be the opposite of b over 2a, where here a would be negative 16. That's the coefficient of the squared term. B would be 28, and c would be 8. Okay. So the opposite of b over 2a is negative 28 over negative 32. The negatives cancel. And it looks like I can reduce this. 4 is going to go in 7 times and 8 times. So that would be at time 7/8. So the t value of this point I know is 7/8. We'll find the maximum height in a moment. Okay. If I want to find the velocity at that time, now there is a little bit of calculus involved here. If I'm going to find the velocity, that would be p prime of t. So the algebra was just for finding that time. P prime of t would be negative 32t plus 28. P prime at 7/8 would be negative 32 times 7/8 plus 28. The 8 cancels with the 32. Negative 4 times 7 is negative 28 plus 28 is 0. Okay. So we've got a horizontal tangent. Now I actually didn't really need to do this work here. I can see from the picture that we're going to have a horizontal tangent. So the object is at its high point at time 7/8, so that would be 7/8 of a second after we threw it into the air. The velocity at that time is 0 feet per second. That's because we've got a horizontal tangent. The derivative, which is the velocity, is going to be changing from positive, because the object was going up, to negative, because now it's going to be going down. When that happens, either the derivative is undefined or it's 0. And I know just graphically, if I've got a nice smooth rounded change like that, it's going to be at 0. Now here I found that 7/8. I described that as the algebra way, by finding the coordinate of the vertex. The calculus way would basically have me answer these questions in reverse order. I can see that we're going to have a horizontal tangent at this point, so that the velocity is going to be 0. So if I calculate the velocity, I could set that equal to 0. That would mean that 28 was equal to 32t. That would mean that t was 28 over 32, which is 7/8. So, just by my understanding of the calculus interpretation of this graph, I can answer this question, and then I can set the velocity equal to 0 and get the time for the vertex. What's nice about that is that this method will generalize to other functions. Quadratic functions, I know the maximum or minimum value is going to be at the vertex, and I know that the input value of the vertex is the opposite of b over 2a. If I have a cubic function, or a trig function, or a product of an exponential and a power function, I don't have a formula for finding the high and low points. But if I know that at the high and low points, the derivative is changing sign, which means it either has to be 0 if we've got a nice smooth rounded change, or undefined if we have a sudden change, I can look for those places and work with the derivative to find the location of my high and low points. And we'll be doing an awful lot of that in chapter 4. Okay, so this is a little bit of a preview for that. Okay, now finding the maximum height, that just means we've got to plug in 7/8. So it would be negative 16 times 7/8 squared plus 28, which I'm just going to write as 28 over 1, times 7/8 plus 8. Okay, so that's negative 16 times 49 over 64 plus, let's see, I can reduce. 4 goes into 8 twice, and here's 7, so this is going to be 49 halves plus 8. And here I can reduce. 16 is going to go into 64 4 times. Okay. So I can say this is going to be negative 49 fourths plus, just getting a common denominator of 4, I'm going to say that's 98 fourths plus 32 fourths. And then let's see, 98 plus 32, that's going to be 130, and then subtract the 49, that's going to be 81 fourths. Okay, so the maximum height is 81 fourths feet above the ground. Okay, excellent. Now, for the time the object lands, and then the velocity there, here, I can't answer this question until I answer this one. I can't just look at the graph and say, oh, I know what the velocity is there. I know it's going to be negative, but it's negative a whole bunch of different times. So I'm going to need to just find when the object lands. So I'm going to set negative 16t squared plus 28t plus 8 equal to 0. I'm going to factor out a negative 4. That'll leave me with 4t squared minus 7t minus 2 equals 0. And then let's see if I can factor that further. Thinking we want a 4t and a t, and a minus 2 and a plus 1. That'll give me 4t squared minus 8t plus t gives me minus 7t and minus 2. Okay, so one of these factors is 0, and I know it's not that one. So either 4t plus 1 equals 0, or t minus 2 equals 0. This would mean t equals negative 1/4. I'm going to reject that one, because we set time 0 as the time we threw the object up into the air. I didn't explicitly state that. That's usually the convention, and that's clear from the way I graphed this. I didn't graph any negative times. This problem started at time 0. Okay. This would mean t equals 2. Okay. So at time 2, the height is 0. That's when we land. So it's going to land 2 seconds after we throw it up into the air. And then if we want to find the velocity at that time, we're simply plugging 2 into the formula for the velocity. Now I've erased that, but p prime of t was negative 32t plus 28. So p prime of 2 will be negative 32 times 2 plus 28. That's going to be negative 64 plus 28. That will be negative, which is good because I can see that it's going down. And let's see, I think that's going to be negative 36, and that would be feet per second. that right? 36 and 28. Yeah. Okay. Excellent. So you'll see a couple of problems like this in the homework as well.